Hello, everyone. Let me get started. I don't have a lot of announcements, and I think I might not have a lot of material scheduled for this week. So it may be a little bit shorter today than normal. So let me kind of go through these. If you have not, send me an email, send me an email. Or if you haven't put your name on one of these, this way I would know. I'll do this maybe. This I would know, kind of have established that contact with you in the first week of class, first 10 days really. On the other hand, if you want to send me your preferences for articles, I think I'm asking about it for today. So soon, maybe tomorrow or the next day or so, I may have that posted, but definitely by Monday I'll have it. I'll have a schedule out. If I use randomness anyway when I create it. I'll take into account your preferences, definitely. 99% of time I'm able to satisfy all of those preferences unless everybody wants to be exactly on the same day.
So this is for the presentation on our article.
Yes.
Okay.
And let me kind of clarify, go through these presentations one more time. So I think most people are not going to have a problem with the quiz. They don't involve any presentation. Homework doesn't involve any presentation. I'm still, again, I'm kind of fighting with some other deadlines, but I want to post them ahead of time if I can. So I'm 2 is going to take me more time to find the data. 3 is relatively easy to make. So once I'm done with 2, 3 will come in quick succession, and that will cover the next month or so at least. So again, quizzes and homework don't require any presentation, shouldn't be any confusion. These 3 things do require some presentations. So let me start with probably the first one that will hit. It's going to be article presentation, let's say. So this, you're presenting somebody else's work. You don't have to build a visualization. All you have to do is understand what they wrote. If they have if they have visualization that they created, they may have a video, a video, show us the video. It makes your life easier, makes it really easy for us to understand what they're doing. Showing a video sometimes, that's where the picture is worth 1,000 words, I think a movie, rather than explaining in words what happens with that technique and so forth. So, so those things, all you have to do is find the article, understand it, and present it to us. That's the presentation there. No, nothing to build. You're not really doing any kind of visualization development. It's just a presentation of somebody else's work. Okay. The next one kind of coming up, the demonstration. On this one, you probably have run into, you worked on the homework or on the project, and you ran into some interesting feature of a visualization or something you used, and that's like a teaching moment. So you do have to have a visualization created, or at least created in front of us, in front of that video. So that is your work. I mean, obviously you're using somebody else's program. It's not 100% your work, but you have to build something for it. So that for the demonstration while presenting. So I'm assuming you have built it before. You're not doing it for the first time when you record yourself at that point. So that one just kind of show how to create something. And then there's the project. And I'm asking kind of a video presentation for your project proposal at the beginning. So that is just a proposal. It's kind of what you have. I put some pointers in. Again, remember that for the proposal, and again, that won't start just yet, but basically tell me as much as you can, as you know, about what you're going to do. Where is the data coming from? Things like those. I try to put some things in here, but you're getting points no matter what. So the more I know, the more I can judge. Not judge, I'm not judging, I'm trying to help. I'm trying to steer you in the right direction because you're getting all the points for all 5 points if you submit something. Can be very elaborate, cannot be, but here I want the video so I can play it in class, basically. It doesn't have to be, like I said, anything you turn in, it's going to be good. So that's the project. Here, I'll try as much as we can. We'll see if we can get everyone. But a lot of people are going to be live presenting or talking to me, basically. So that's a presentation of where you are with your project. Shouldn't be that complicated. So that's all the project. And then there will be, at the end of the semester, you're going to show me your finalized project and what you have. Here is our solution. Here is what we tried and discarded, things like those. Here is our theory. So going through all of these things. So that's but like I said, right now we're going to have these three that come up. One is obviously a proposal of kind of what your team is going to do. I don't expect you to have a visualization done. Just maybe collect some data, have some ideas, and kind of talk. Think about how would anybody would use those, and then that will prompt me to kind of keep on going and tell you more about what I want for the project, because I know everybody has a slightly different idea on how this will go, so I'll try to get everyone on the same page with me on that. So like I said, so for the most part, these two are completely different from each other. They're individual. The project is going to be team-based. And I'll have, like, the teams are going to be due. I gave you until next Wednesday to tell me team preferences, if you know anybody in the class. If not, I'll randomly assign people. And then after Wednesday, probably Thursday or Friday, I'll have those posted as well. So that's kind of where we're going. So project, the only thing you do in teams is the project. Everything else is individual. Okay, so that's another way of putting that together. And then we'll talk about this recap summaries all the way the semester, almost like a final in many ways. So hopefully that clarified some of this. Article presentations, only graduate students need to do it. And please do not, it doesn't happen often, but I had somebody who tried to recreate somebody else's. No need to do that. Do not build anything. So you don't, it's just an article presentation. Present the article. Use any materials the original authors have. Like their publication, you can take pictures from their publication. Like I said, if they have videos of the system, you can use their videos that they created, but use only the original authors. Everything else should be done by you. Like the slides should be done by yourself, by each individual student. And obviously the presentation, hopefully with your face, I don't know, with AI nowadays, just that's probably too much computational power to make a custom and time. But we're getting there soon. It's like, oh, why don't you put my face on this video? So I think that's kind of all the announcement. Here, and I think I looked last time, so here I'm only going to slide 16. Once I hit that, I'm going to stop. So these are already pre-recorded. I think we were already at slide 12. That's why I thought we're not going to have a lot to do. In previous years, apparently it took a whole week to go through these. Nowadays, I either went a little bit faster, you guys didn't ask that many questions, I don't know. But we're going to probably not take not going to need the entire class period today. But that's all I wanted to cover this week, and then the next week it's already set up on February 3rd. Again, this is coming up. And then starting after next week, we're going to have quizzes. Quizzes are going to start to pop in. But for now, I think we, like I said, first class period was waiting to see more people join. Actually, I had one person who left and maybe one who joined, and I think there's one more on the way, as far as I know. Not sure if they joined yet. So that kind of happens. In the first week, there's a lot of, not a lot, but there's a little bit of churn. Okay, lectures. I will kind of share my screen. I need to load that here. I think it's this one from last time. So we're talking about visualization in general, kind of introductory stuff. And in a way, visualizations can work like our external hard drive. We don't have to memorize. And sometimes can work like our, we can use our visual system, the way our visual cortex, which we don't control necessarily. We don't know how our brain interprets objects and it does 3D. You know, it just happens. We just take the results. But sometimes we can use that power to process problems a little bit better. Makes it easier for our conscious mind, for our cognitive kind of problem-solving mind to deal with them. I think that's kind of the review of things that we discussed last time. So we were here, that was the last slide. That's pretty much what I said. Another thing to consider is that many types of information we look at are not just, this in a way, it's just a handful of stations. Tic-tac-toe is just 9 squares, no more. What happens if things get larger? What if we're dealing with a data set that has 1,000 elements, 2,000 elements? How do we react to that? How our visual system will react to, you know, does it get overwhelmed? What can we do? What are some ways to deal with larger things? That's why tic-tac-toe is easy, because it's only 9 things. It doesn't get any larger. But can you play tic-tac-toe with 4? And I don't know. There's other games that kind of expand that, so it can get more complicated. So that's, I want to point that out. That really, all of these problems at the beginning are just pointing out that, you know, in ideal situation, visualization works really well. But most of the time, it's not going to be as clear or as clean or as effective as some of these ideal situations. So definitely we want to, it's the name of the course is information visualization, so data visualization, maybe could be another name for this course. And in general, it provides us something about the data. It helps us think, it helps us use the data to solve a problem. It helps us, there's more than one thing. So it's not exhaustive, but discovery. We're trying to find patterns in the data. Trying to find, you know, Waldo. Where is Waldo? What are some patterns that we can see in this data set? Sometimes visualization are used for decision making. I'm trying to see which stock I'll buy, which dishwasher do I want to buy. Here are all the dishwashers with their properties. Homework 1 is kind of like that, like a dishwasher thing, trying to pick out the best one. Sometimes visualization helps us learn, remember kind of what happens. Again, I can look at the stock market, or I'm not sure if you've seen traders sometimes have something called a T. There's some traders that do technical work. They look at the shape of the prices, how it change over time, and they say, oh, we can see a T shape developing here. So they understood kind of what happens in the stock market, so they remember that. So they see it back happening and say, oh, normally after a T or a shoulder pattern, this is what happens. So they kind of can guesstimate what's going to come out that way. We can use visualization to transfer ideas for presentation. I present something to you. So you're showing me your article. I mean, the article that what you understood about that article, you're presenting it to us. So you're trying to figure out a way to transfer information from one person to the next. Another thing to consider that for reasonable size data, we don't need computers. People used visualizations a long time ago. And they were on paper or they were on a billboard. Like the subway visualization happened probably before computers. People still had subway, so they had to go through them. The only thing that's different on a computer versus paper is that they can be interactive. They can move. They can change over time. Paper is set in paper, set in stone. It doesn't change. So that is the only difference. Other than that, if we computer and paper visualization, many times there's a lot of overlap. All of these things apply to whatever applies to computer applies to paper, to static visualizations. Now, when we're dealing with reasonable sized data sets, thousands of elements, many times it just makes sense to have them interactive because you can take things out that you don't want, put things back in, rearrange information. So a lot of the techniques that we're going to look at, well, almost all of the techniques that we'll look at this semester, they assume that they're on computer. So they may have some interactivity attached to the visualization. And there's, I call it scientific, but that maybe it has more than one, but there's different types of visualizations out there, even looking at data. So there's some visualizations that don't look at data, like, maybe movies. Star Wars is trying to visualize something. That's not really data visualization. It's more for artistic reasons. But even considering data information, things that, have lots and lots of things that you would put in a database. There's some visualizations, scientific, but in those, I call them that, but I just think some of them are scientific, some of them are more like CAD design, having the duct system in a building, design in 3D. So I kind of, in those engineering diagrams, having maps of the world. Again, I don't have a good name for it, so I call it scientific. But there's some science involved. Some of them are scientific. The difference there is data, but that data has a very well-defined geometry. A map of the world has a geometry. I know each coordinate. I know if it's a mountain or a plain. I know where, the ocean begins and the land ends and so forth. So if I have an MRI of my brain, and you're going to figure out that I'm an alien, no, but it's a 3D representation. I know exactly where each data point is in that representation. So we're not covering that in this class because if they have a good shape, 2D, 3D, the problems that they're dealing with in that kind of visualization are slightly different than we're dealing with in kind of pure data visualization. Why? The 3D MRI, the biggest problem they have is navigating through the MRI, looking at, because it's a huge data set, actually. An MRI is probably a few gigabytes of data. And just having a graphics card or something that allows you to go really fast from one point to the next, it's complicated. Zoom in, zoom out. So they have other problems. They deal a lot with, in this environment, they deal a lot with efficiency. How fast can we display that? How fast can we make a change in it? Another problem they kind of have with all 3D visualizations. So think about for a sec. You only have a second, so I'm not sure. So think for yourself. Do we have 3D vision, or our eyes, our visual system is 2D? Is 2D or 3D?
3D.
Can we see to here? It's kind of 2.5.
Okay.
And if I replace the air in this room with sand, you won't be able to see through it. We can't process. We don't process volume. We process surface. I can see the surface of your body, but I don't see through it. And the only reason I can see you is because the air is transparent. So the only volumes we can see through volumetric data needs to be transparent. With an MRI, how do you deal with that? How do you see what you want to, but you don't see what you don't want to? You know, what parts of the brain? Because there will be parts of the brain that sit in your way to seeing the other parts of the brain that are important, where you're looking for. So again, even with interaction, like I said, not only efficiency, but the 3D world has its own problems. And that's one of them, the fact that we really don't see, we see surfaces and that's it. I had one time, there were some geologists here, they were running ground penetrating data, radar, ground penetrating radar to detect water leaks. So they would, you know, if you see many times, if the pipe is underground and it leaks at point A, it doesn't mean the water comes straight up. It actually goes through layers of earth, and it may come up, you know, 200 yards further. So, and they came and we did a 3D visualization, and I was like, well, we need to take some of this out. No, we want to see everything. You can't see everything. If you see everything, you only see the edges of everything. You don't see inside the everything. So very quickly realized that problem. Again, that's not there are different problems to deal with in that world, in the scientific visual. Some of the maps, they have their own other problems, but GPS data, think about like that. Again, also with GPS is related to efficiency. How fast can we move through the world? Sometimes it takes a while to update. That's not something we're concerned with in this class. So this is information visualization. So we're just going to look at data that is abstract. The data that we look at doesn't have a shape. I want to look at stock market. What's the shape of the stock market? Doesn't really have a shape. I want to look at a database of human resources. You know, like HR data that they have in there. I want to look at a database of my customers. What shape do they have? They don't really, do I care about their shape? No. I care about other things. So a lot of time, what happens in information visualization is we have too much freedom. I can use any shape I want. So that's really where the problem is. Which one do you pick? You have way too much freedom. And again, I'm trying to convey some of this through the first couple of homework assignments. And some of you ask me, you know, where do we start? I don't know where you start. And I want you to realize that you can start everywhere. It doesn't mean that you come up with a bad visualization or a good visualization or a perfect one. There's no perfectly good one. There's no perfectly bad one. Everything is going to be a trade-off. You have to make a decision and see what you get. And again, for this first homework, what I want you to do is kind of try a few things and see which one works the best at the end of the day. There's no perfect one. And if I have an idea, I'll kind of put it together. You may have an idea, and the other thing that you can do is experiment with some craziness on the first one, at least. It allows you to do that. So if you have something that you thought of, or see if you can maybe draw it, because I left that option open there. But talk more about that homework in a second. But again, going to, in general, the problem is how do I look at this day? How do I look at what, I want to visualize how the laws of the United States change over 100 years. Do they have a shape? There's a lot of words there and things like that, but what am I visualizing? So I have a lot of freedom and too much freedom. And that's where the problem exists with. That is the problem, but it's also not a problem. That's an opportunity and the problem. You take it. So like I said, I was trying to say, there's a continuum. You ask, it's one of those things. You ask 3 dentists, they don't, which 3 out of 4 dentists recommend. That's kind of with visualization. There's no clear answer where information visualization ends and scientific visualizations begins. But I put something here. I think we're gonna talk about it next. Minard's graphic is here. I kind of inverted it. And then this is a storm cloud, and this is where it's a storm cloud, and you can kind of see the temperature distribution and maybe wind vector. And this is just temperature distribution or something like that. And this is an engineering diagram. So these two definitely have a clear 3D model. This one is very data oriented. That one is a map, a 3D map of the ULR campus. But it starts to be in the middle because now I'm looking at here are the rooms and what each room has. If I start putting schedules in there, here is the room and here are classes at this time. I'm starting to kind of move into away from just the pure 3D visualization and starting to add information that has no shape. Schedule doesn't have a shape necessarily. So there's always a continuum. I'll try to, even for articles, sometimes some of you may go way too much on the 3D one. I might pull you back, or if there's a little bit of information in there that's not spatial, I may let it go. Just like I said, there's no clear thing, but we're trying to focus more on the data, things that don't have a shape necessarily. Same thing with GIS information. That's a map. Clearly has a shape. But if I start putting in information about population, income, and things like that, doesn't have a shape. I start kind of displaying it in there. So I can take some of these things that have shape and combine them with things that don't have shape. And sometimes it helps, sometimes, but it's difficult. Especially for the projects, you're going to hear me that. But it's difficult to get a map to behave well once you start adding non-spatial information to it. Okay, and this is the end, the last slide. I would be excommunicated from the, I don't know, it's visualization community starts with this one. If I don't talk about it first, I'm not a good, they're going to kick me out of the community. No, I'm kidding, but that's kind of, so a lot of the first ones, this was made on paper, and I think Minard presented it to it's a bunch of it happened in London to the, it's not a did they call it Congress? No, the House of whatever, House of Representatives, things like those. And actually, the first couple of them that I have here are also morbid, but they are very famous, and we have to talk about them. So what this shows is Napoleon's march into Russia and back. So you might probably know from history that at some point Napoleon decided to attack the Russian Empire, and he didn't quite succeed. He won every battle except until that one. Everything he kind of put his mind to, and that's where he failed. And here is kind of a representation of that. What are we seeing here is that the width of all of these represents the size of Napoleon's army. Everything that's, and there's I don't think this is the original Minar graph. It's something I could find. But there's variation. So in this case, everything brown, the army was marching towards Moscow. Everything black, the army is retreating. So attack and retreat, that's kind of what you see there. There's a little bit of a map component, but not, you won't be able to recognize anything in here. So you can see how big the initial army was and how small the retreating army ended up being. So I can't even draw a line there. It kind of shows, first of all, you see that big thing, kind of how many troops were lost there. You can see that in some of the marches, they sent some of the troops out kind of to wait for them when they return to reinforce them. But even they had losses. Some of the names here are actual battles when they occurred. And then you can see some of the rivers. You can see this is a river right here. And then at the bottom of the graph, we have the temperature. I can't remember, I don't know which temperature is represented here. Like I said, it's something that I found that I could include. It may be the temperature, well, based on these lines, is the temperature on the retreat. So one interesting thing right here, one of the reasons Napoleon's army lost is because he went there late in the year, and the temperatures dropped, and the army was not equipped for low temperatures. So that's one reason. And then over there, the reason they put the rivers is that they lost people while they were crossing rivers. And kind of the same river, obviously they crossed the same river when they in the brown thing, but they don't show it because it was really cold, so it was frozen. On the return, you can see the temperature started to warm up a little bit before they reached the river. And what happened is ice gave in, and they lost horses and a lot of equipment and people trying to cross on ice. And that ice cracked and they fell through. So that's the reason you see some of the rivers they put them, especially during the warm-up. So that's where they lost about half of the people that were there. There weren't that many left, but when they crossed the river without any battle. So this picture kind of shows a story, has a bunch of information in it. Like I said, you won't recognize any map. Maybe where the rivers are, they're lined up from east to west. So really the only thing that matters in this picture is east-west. It doesn't mean that they were up north when they left, when they went towards Moscow and they came back through the south. It's just the picture is segregated that way, so you have the top and the bottom, so you can kind of see what's going on. They probably use the same way to come back as on the map as far. So this is not a map by any means. It's just a way to show the what happened during that march, and it kind of makes a big point, especially the segregation between brown and black. You can see how big the army was on the way there and how small it was coming back. So that's one example. So we'll take it back from here. I think that's a famous example of information visualization or data visualization. I really don't know where data ends and information begins. So both of them are probably accurate description of this.